Hello everyone, myself Esha K. Joshi, lecturer in Electrical Engineering Department, VPMP Polytechnic. My subject is Analog Electronics, unit name is Field Effect Transistor, and today we will discuss about the construction of junction field effect transistor. Our objective is to understand the construction of p-channel junction field effect transistor and n-channel junction field effect transistor. We will also discuss about how the depletion region forms in JFET and voltage polarities and current direction in JFET. As we have discussed in our last video, different types of FET. There are two main types of field effect transistor. One is junction field effect transistor and another one is metal oxide semiconductor field effect transistor. So here we will discuss junction field effect transistor in detail. So the junction field effect transistor is also divided in two categories depending on their structure. One is n-channel JFET with electrons as majority charge carriers and p-channel JFET with holes as majority charge carrier. You can see the symbol on your screen for n-channel JFET and p-channel JFET. Here this is the symbol of n-channel JFET where the arrow points towards the vertical line. This arrow points towards the vertical line, and in this case this vertical line represents the n-channel. Likewise, in symbol of p-channel, the arrow points away from the vertical line. This arrow, you can see in the diagram, the arrow points away from the vertical line, and in this case the vertical line represents p-channel. This vertical line represents p-channel. So you can see the symbol of p-channel and n-channel JFET. There is only one difference between this. In n-channel symbol, the arrow points towards the vertical line, and in p-channel JFET, the arrow points away from the vertical line. So that is the only difference between the symbol of n-channel JFET and p-channel JFET. And there are three terminals of both the n-channel and p-channel JFET. This is drain, this is source, and this is gate. So there are three symbols: drain, source, and gate. Now let's see the construction of both p-channel JFET and n-channel JFET in detail. So let us start with the n-channel JFET. You can see in the diagram that n-channel JFET consists this n-type. This is n-type semiconductor bar with two p-type heavily doped regions diffused on opposite sides of its middle part. And these p-type regions form two p-n junctions. The space between the n-type region is known as channel. These p-type regions form two p-n junction. This is one p-n junction and this is another p-n junction. This is one p-n junction, this is another p-n junction, and this space between the space between the n-type region is known as channel, and that is n-channel. Both the p-type regions are connected. You can see in this diagram both the p-type regions are connected internally and a single wire is taken out in the form of terminal known as gate. The electrical connections known as ohmic contacts are made to both ends of n-type semiconductor and are taken out in the form of two terminals known as drain and source. The current consists of only one type of charge carriers, electrons, in n-channel JFET, and that's why the field effect transistor is known as an unipolar device. The supply voltage is connected between the drain and source, between this drain and source terminals of JFET. Whenever a voltage is applied across this drain and source terminals, current flows through the n channel, this n channel, due to electrons as the majority charge carrier. So this is the construction of n channel JFET. Now the construction of p channel JFET. It is very similar to construction of n channel JFET. The only difference is it consists of this p type semiconductor bar with two n type heavily doped regions diffused on opposite sides of its middle part. The n type regions form two p-n junction. Here also it forms two p-n junction. This is one p-n junction and this is another p-n junction. So two p-n junctions, and the space between the p-type region is known as p-channel. Both the n-type regions are connected internally. Here both the n-type regions are connected internally and a single wire is taken out in the form of terminal known as gate. The electrical connections known as ohmic contacts are made to both ends of p-type semiconductor and are taken out in the form of terminal drain and source. The supply voltage is connected between the drain and source. Here drain and source, the supply voltage is connected between drain and source terminals of JFET, and whenever a voltage is applied across the drain and source terminals, holes flow through the p channel, and due to holes as the majority, and current flows through the holes as the majority charge carriers. So this is all about the construction of p channel JFET. So the construction of n channel and p channel JFET is almost similar, but the difference is the material by which it is made. So in n channel it is made of n type semiconductor bar with two p type heavily doped region diffused on opposite sides of its middle part, whereas in p type channel JFET there is a p type semiconductor bar with two n type heavily doped regions. Now let us see how the depletion region forms in JFET. So let us consider the n channel JFET. You can see in the diagram, it is a diagram of n channel JFET. So here N-type channel is constructed and P-type gate is there. This PN junction is always reverse biased in JFET operation. You can see in this diagram here, this is P-type regions and they made two PN junction. This is one PN junction, this is another PN junction, and this PN junction is always reverse biased in JFET operation, and the reverse bias is applied by a voltage VGS connected between the gate and source terminals. Here the positive terminal of the voltage VGG, positive terminal of the voltage VGG is connected to the source and negative terminal to the gate. Now whenever a PN junction is reverse biased, the electrons and holes diffuse across the junction. Here is the junction, so where the electrons and holes diffuse across the junction and leave behind the positive ions on N side and negative ions on P side. So the region containing this is the region, here is the region which containing these immobile ions is called depletion region. As the reverse bias voltage across the junction is increased, the thickness of this depletion region will extend equally in both the regions. If one side of the junction is heavily doped as compared to the other side, the depletion region extends more into the region of lower doping. Now, when there is no applied voltage between the drain and the source, when there is no applied voltage between this drain and source, the depletion region is symmetrical around the junction. And the conductivity of this depletion region, this is the depletion region. So conductivity of this depletion region is 0 since there is no mobile charge carriers in this region. And therefore, the effective width of N channel is reduced. It further reduces with the increased reverse bias voltage applied across the gate and source terminals of JFET. And the reverse bias across the gate source junction of JFET can also be achieved simply by applying a voltage across the drain and source terminals. So this is how the depletion region forms in JFET. Now voltage polarities and current direction in N channel and P channel JFET. So you can see the diagram in N channel JFET. VDS is positive. VDS is the voltage between drain to source, and VGS is always negative, where VGS is the gain to source voltage. VGS is gate to source voltage, and the current direction of current is from drain to source. So here ID is drain current, here ID is drain current, IS is the source current, and IG is gate current. In P-channel JFET, VDS is negative and VGS is always positive. VDS is negative and VGS is always positive, and the direction of current is from source to drain. So this is about voltage polarities and current direction in JFET. In our next video, we will discuss about the working of JFET. Thank you.